All right, so let's answer these 4 questions. Population of trees have heights with a mean of 110 feet and a standard deviation of 20 feet. Suppose a sample of 100 trees is selected. Find the following. All right, so we want to find the mean of the sampling distribution. Let's recall from previous slides that the mean of the sampling distribution is the same as the mean of the population. And the mean of our population is 110. So this is the easy one. The mean of the sampling distribution is the same as the mean of the population. All right, the standard deviation, on the other hand, the standard deviation, and I'll bring it down here so they're not crowded together. The standard deviation of the sampling distribution is equal to the standard deviation of the population divided by the square root of the sample size. All right, so for us, that's 20 is our standard deviation of the population divided by the square root of 100. So this ends up being 2. All right, so this is 2. Let's go to number 3. Now, let's notice the very important significance between this one and this one. All right, this one is X bar. It's the mean. It implies that there's a sample. We can't get the mean unless there are multiple data points. So this one uses the sample. This one is just X, a single value. All right, so X bar, we have 100 trees. Let's find this probability. So we're going to use our newer z-score because we're going to have to use this standard deviation since we have a sample with X bar. All right, so 108 minus our mean of 110 over the new standard deviation of 2. And this is negative 2 over 2 or negative 1. So we're going to look up negative 1, but let's remember that the chart always gives us the area or the probability to the left that is less than. So this is a greater than problem, and recall with greater than that whatever we get off the chart, we've got to subtract it from 1. So let's look up negative 1 on our chart. Here it is, and that is 0.1587. All right, so 0.1587. And then we'll go ahead and subtract that from 1 to get the probability that X bar is greater than 108. So it's 0.8413. All right, now number 4. We were able to do number 3 because our central limit theorem says that if we have sample greater than 30, then we can use the sampling distribution of the mean, and it's approximately normally distributed. All right, but if we have a single value, we need for our mean and our standard deviation to be, for our distribution to be normally distributed. And let's notice here that nothing here says that these trees are normally distributed in their height. So we actually can't answer number 4. Number 4, we need a normal distribution in order to answer number 4. And this question is more than likely going to show up on your final. So watch for it. We need a normal distribution in order to find the probability of a single value being greater than 108. And we have nothing here that says we have a normal distribution.